morning. How is everybody? Excellent. Okay, so today I am hopeful. Oh, there you go. Yes. So my name is Patricia Aas. I am a programmer. And today I'm going to talk a little bit about reading other people's code. So very short about me. Been programming for about 18 years in many different places. Currently I work on the Vivaldi Browser, who also gave you the water bottles, which was very good. My Twitter handle is there, but it's occasionally on the slides, occasionally being every slide. So there you go. So this is the outline of the talk. So basically, a short introduction, then a little bit like prep work, 10 techniques, and then a little bit of a conclusion, which is kind of given because it's on the slide, which is different is good. So there you go. So you got someone else's code. It's not really a good feeling in general, and you can tell from her face, she's not happy. But what is most important, I think, when you get into the situation where you have to actually learn and internalize and imagine somebody else's code, is to view it as a learning experience. So this is not a code review. And this is probably the most important slide. Because if you get past looking at the code that you are faced with as something that you're critiquing, but instead something that you're learning, then you're going to get a lot further. So this is how I imagine things. That when you're programming, you have this mental machine. You're building a mental machine. This mental machine has movement. When it's running, when it starts up, when it gets a request, things pass through this mental machine. But when you program, you have to serialize this mental machine into code. And code is very linear. You write like page up and page down. But when code runs, when the machine actually boots in the machine, in the computer, it will have a very non-linear movement. Things will jump from one class into another. Things will pass through layers. So the structure of your program on disk does not really reflect how the program behaves. So the reason why you often get kind of stressed out when dealing with somebody else's code, like imagine your clone, you have this favorite framework that you really like, and you clone it from GitHub, and you're thinking, I want to contribute to this cool, fantastic project. But the thing is, when you get it, it's just files and directories, and you don't have a mental model. And what is very easy to become very stressed out about this. So what I'm going to try to do throughout the talk is give you different techniques on how to approach this. And these are not in sequence. The idea is to kind of jump around a little bit and slowly but surely build up your own mental machine from somebody else's code. So before you start, you need to get the code. Some people try to do this, like having the code online and trying to reason and understand somebody's code that's online. I would not recommend that. Basically because it leaves a lot of tools that you can't use anymore. So get the code locally, put it into source control if it's not in source control, put it into as smart of an IDE as you can afford. Then try to build it, try to run it, and preferably in a debugger. Now the idea here is do as much of these things as you can. If in addition to this, try to run the test, try to have the test running framework, and get as much of this machine actually running, because a lot of your building of the mental machine is going to be observing the program running. So this is my scale. This is where I come from. I worked on the original Opera browser. Now I work in Vivaldi on the Vivaldi Browser. And Vivaldi Browser has 600,000 files. This is not something you kind of start at the beginning and then you read it until the end. It's not, you can't work that way. Most people have a much smaller scale, but this is my scale. Okay, so 10 techniques. And these are the techniques. We'll get back to the slide occasionally as we go through, so you'll see where we are, but I'll just list them. So first one is grepping. Where is this button? following input events. What do the tests do? Refactoring, reading Maine, the graphical layout, runtime investigation, reading a class, retelling, or rubber ducking. So Grepping, which I think is a fantastic name, although you probably won't use grep. You'll probably use your IDE. The idea from Grepping is basically to try, and this is generally where people start, because you don't know where to start, so this is where they start. You go like, okay, I have no idea how this thing works, so I'm going to take a string somewhere, from a button, or a dialogue, or from the command line, or from the logs, and they're just going to grep for it. Try to figure out where it's coming from. It's a perfectly valid thing, and people do it a lot. I would probably say that like reading somebody else's code is 20% grepping. Okay, so, and we're going to use that technique for this next one. So where is this button? When you're looking for the code behind a button and trying to understand how it works, it's a very good way to kind of get a feel for how a GUI application works. So you try to grep for the button text. Oftentimes, if it's a localized application, you will end up in some kind of mapping file to some constant. So then you grep for the constant. And then you kind of continue like that until you actually find the definition of the button. When you find the definition of a button, you'll probably close by find some kind of on-click handler. Now, this is when you really want to have this in a debugger, because now you set a breakpoint on the on-click, and you click the button. So what you're going to get is two things. You're going to get a runtime view of the widget hierarchy with this button as the focus. But you will also get the stack from how the input event went all the way up to you. And this stack is really, really useful. So I would just like copy this stack into a text file and print it and just put it next to your computer, because this will show you how input events are propagated, which is very useful. But you can also then, when you have the runtime view of the widget, you can traverse it up into the root. And for each step up the widget hierarchy, try to write down what are the names of these widgets as you go up. And this will generally map to the window. So you will get, it will make sense in general. When looking at the window and looking at these things, you will get a feeling for how the main window is laid out. But like all of these things, I wouldn't do it too much. Like when you've done a little bit, just put it aside and do something else. Because all of these techniques will inform each other, so it's an iterative process. Okay, now, following input events. Now, this is a little more of an advanced topic, and it's mostly if you are looking at GUI frameworks. So you're trying to figure out how the GUI framework works. And this could be anything. It could be something that is low-level native kind of a GUI framework, or it could be something that is a JavaScript framework like React, for example. And it's basically trying to figure out how it works. So the best two ways of figuring the underlying architecture of your GUI framework is figuring out how do events come in, and how is the final frame for the window produced. Those are like the two main functions of a GUI framework. They need to be able to give you input events like clicks and mouse move and all of those things, and give it to the right widget. But it also needs to produce the final frame. So if you manage to find these parts of your GUI framework, you have basically uncovered the skeleton. So what do the tests do? And when I say tests now, I don't mean unit tests. Unit tests are generally not very useful in learning other people's code. Unit tests are very good for rescuing you when you're trying to mess around in somebody else's code. But it doesn't really help for understanding. What really helps is integration/system tests. So if you have a thing that actually launches your entire thing and exercises it in a proper way, then you will see how is it launched, what kind of interfaces does it have, how can you exercise it. But at the same time, you can also try to make a test. And that will also teach you a lot about this interface of the application. And then we come to the hard part, because this one is a risky one. So refactoring. Now, with refactoring, the reason why I say it's risky is because refactoring is very opinionated. Like I said before, this is not a code review. And when you are dealing with someone else's code, you're also dealing with that someone. And so most likely, if this is a project, then you want to contribute to this project. You want to have a good relationship with these people. You kind of want them to like you. If the first thing you do is go and you just refactor all their code, and you're basically saying your stuff is crap and I'm better than you. So this is what I'm saying, is that you can do refactoring for your own learning, but you don't have to give it to anyone. You don't have to show it to anyone. So don't get attached to it, but use it as a learning exercise. Because, and that can be anything from a style-guided refactoring, because it basically makes you go through the code. Or it could be something more architectural, trying to pull two classes apart, or trying to introduce layers, or something like that. And you will learn a lot about the code doing these things, but it's very hard not to become attached to it. So you kind of have to go in with that attitude. I am going to throw this away. Because you have to decide, because it's going to be very difficult. Okay, so reading main. Now, main is in quotation marks because it's not necessarily called main. It's whatever function drives execution in your module or program or library, and it could be anything, right? But in a standalone kind of C-like program, then it's generally called main. And basically, that is the how. Like I said, with this mental machine, the main will show you how this mental machine starts. Like that is where you will see where somebody puts the key in the ignition and starts the machine. This is where it boots the whole thing. And it will give you a lot of idea on how the architecture is actually hooked together, because that you'll see all the pieces being put together. But very often people have kind of tried to make it cleaner, and so they will push things into other methods that have like nice names. So you might have to recurse a couple of levels. But what is most important here is to take notes, write down all important classes, functions, things like that. Especially pay attention maybe to parameters that are being passed. Like if you have a special type of parameter that is being passed around to all of these functions, it probably contains very important state or very important control functions. So those are also very interesting. So what I would say here is take notes, draw, and put it next to your stack trace that you had from your button, because this will also give you a good overview, and it's something that you can go back to later. Okay, so then you have the graphical layout. And this is trying to figure out how the whole application deals with UI. And basically, you will generally have a main window, and it will have its main layout. You might have layouts for smaller things like dialogues and things like that, but you will generally have one main layout. This main layout will change based on a possibly implicit state machine. So this state machine will basically be use cases. So imagine, for example, for Gmail. If you go to Gmail, you will have, your first state will be login, for example. And if you can't log in, you have to say, I don't have a user. Then you go into add user. But then sometimes they will say, like when you've added the user, sometimes they'll send you back to log in. And then you still have to log in, even though you just set your password. And then you go to view emails. And then you have the list. And what you will see with all of these things is that it is a big change. The main layout has massive changes. It looks totally different. So the state machine that will change from one layout to another layout is a very central component in the architecture of a GUI application. So if you manage to figure out where that code is, you have found the core part of all of the UI handling and generally all of the state handling in a GUI application. And each state usually maps to like a use case. So you will have something like, login or view emails or compose email. They will generally map to something very high level. Okay, so then you come to runtime investigation. And a lot of people think that you can just do this, but you need a lot. But this is a very useful thing. So in runtime investigation, the first thing we should say is that applications are different. And I've made like a rough outline of different types of architectures. If you have an application that needs to be responsive in some way, generally for user input or things like that, you will generally have an event-driven application. So there will be a main loop somewhere. You might not see it, but if you have a tendency to write like click handlers and stuff, you have a main loop. You might never have seen it. It's probably in a framework somewhere, but there is a main loop somewhere. And you will generally have async things that you do because you're trying to keep responsive, because you can't block the main thread or nobody can click anything, which is unfortunate. So, but then you have a request handling type of application that generally you will see those kinds of things back-end. So you will get an HTTP request that you need to handle and you need to get a response. And this is much easier because it's very delineated. You know exactly, you get the whole thing and then you do your thing and then you return it. And it is very synchronous because you kind of have to finish everything before you can return. So it makes it easy. So generally on the server side, you will just spawn a thread to handle this request. That thread can be mainly single-threaded. Maybe if you want to be fancy, you can do some kind of multi-threading, but it's always going to be very limited because you have to wait in the end, because you have to finish the request. So generally, with request handling or command line tool, which is the other one, they're both mostly synchronous. So you will have a much easier time with things like using the debugger and stepping around. But in an event-driven application, that is going to be very difficult because you will have something doing something, and at a certain point, it will post something asynchronously, and then it will just return back. And then later, some handler will be spawned off of that. So using your debugger for that will be difficult. So to do that, you have to set multiple breakpoints, many places. So basically, you want to combine techniques. And how much you use each really depends on what kind of application you're using. So you use the debugger to examine the runtime state and get the stacks. And the stacks will give you an idea of how this functions. How did I get here? And who cares about me? Like, what kind of other things are in my chain of command? But setting, if you are in an event-driven application, setting breakpoints is kind of the main thing, and you don't know exactly where you are. You don't know the code, right? So basically what people generally do is you read the logs, and you add logs. You add logging everywhere. It's like in the beginning, and this is one of the good reasons why you need to put it in source control, because on occasion you just want to reset hard, because you have put logging everywhere to try to figure out how things work. But as you've added logging and you see, okay, so after this, then I end up here. Okay, so then I'm going to put a breakpoint there. And then after this, I end up there. Okay, I'm going to put a breakpoint there. And then you just start running it, and you stop on the first breakpoint. Okay, fine, you look around, and then you just continue, and you hit the other breakpoint, and that's how you get the kind of synchronous debugging in an event-driven application. So I will expect you to add lots of code. Like add lots of logging, add tests, add assertions to try to say like, okay, when I'm here, then this can't be null, or this thing is this way. Add a feature. Just try to add a button next to the button you're looking at and try to hook it up. And just doing that will probably teach you a lot about how this works. But I'm saying also that you don't have to keep any of this. You don't have to feel like just because you wrote code, somebody has, like, it has to go into GitHub. This is a learning process. So just feel free to just like get reset hard when you've kind of gotten past that point. Okay, so now you've done like the big high-level architecture stuff. But at a certain point, you've got like a handful of classes or modules or whatever you'd like to call them. I say class a lot, but a class is basically anything that has an interface. So it doesn't have to be a class. It could be anything, right? But you narrowed it down to just a little bit, and then you can look a little bit deeper. Because in the beginning, you kind of have to skim the surface a little bit to get an idea of the high-level overview. So, reading a class. And even here, I say stay on the surface as much as you can, because this is a breadth-first kind of exercise. If you go too deep, then you end up not going anywhere. So first of all, look at what kind of interfaces does this implement. That basically means what are the public view of this thing. And then try to grep/search/usages and find out what other people view this thing as. How do they use it? What kind of functions do they call? And these public functions, the ones that people use, that will be your new mains. And then you can use your main technique. Go and read them. And those are the ones that I would say read them top to bottom. Just like going through, writing down, drawing. Okay, so first this function, and that it returns this thing, and then that's given here. And just like, there's no structure to this, so use whatever drawing technique you feel comfortable with. But it's very easy to get confused and lost. So it's nice to have these notes to come back to. Okay, so now this is like the final, but also kind of the motivating technique. Retelling or rubber ducking. Now, rubber ducking is a technique where, and you guys probably all have done a variant over rubber ducking. It's basically when you go next to your coworker and you go like, I don't understand why this thing doesn't work. And they're like, okay, so what did you do? And then you're like, yeah, but I first did this, and I did this, and then I did this, and then never mind. Because you know exactly what you did wrong. Because when you explain it, then you have to serialize this model in your head, and then suddenly you realize where something went wrong, or where you didn't have enough information. So just the fact of the exercise of explaining something to someone, and that could be write a fictional, possibly, blog post, write documentation, make an internal presentation, because maybe somebody else also needs to learn this code. In my experience, an actual physical rubber duck is not a very motivating thing to talk to. And it doesn't really work in like an open plan office. So it's like you can bring the duck to the bathroom, and it's like, I have a thing. But mostly I would say go for a person, or try to write it up, try to draw it. Like take your notes and like clean them up. Almost every project on Earth is going to be absolutely ecstatic if they get a pull request on documentation. Because nobody wants to write documentation. So if you come into a project and go like, I have some documentation for you guys, they're going to be like, oh, we love you. Do you want to stay? So definitely, just try. You can use this as a motivating factor for getting something out of it, right? So, my conclusion, different is good. Great code should be personal. That means when I say this is not a code review, it is not a code review. You have to accept the code as it is. Because accepting the code is accepting the people. People will write this code. It is a part of them. We try to pretend like, oh, don't take it personally. And that is absolutely a lie. It is personal. If it wasn't personal, then you're not doing your best. So we want people to take pride in their work. So you have to treat people with respect, but also if you're learning, it is impossible to be in a critiquing mode. If you're critiquing, you're not learning. So this is sort of like learning to love other people's code, even though it's not like your code, and learning from their code. Like maybe you will find like, okay, I like the way that this person does this thing. I like this way of doing that. That's pretty elegant. I'm going to try that in my own code. So style is individual. We are all individual. And be accepting. Because we want everyone to feel safe to be themselves. And we want everyone to feel safe in their teams. And being accepting and being in a learning mode with our coworkers and with others makes an environment where we can all flourish. And that's my talk. Thank you.
Okay, thank you. That was fantastic. So I really like that, just the whole idea of it, because it's so important, I think, that we spend all this time writing code, but at the end of the day, humans are reading it and writing it, and we cannot eliminate that yet. I don't know. For the near future, we can't eliminate the humans that are interacting with code.
Yeah.
And so I think it was really important what you talked about. What are ways do you think that people can build this into their team culture and like routines and things like that? And have you seen that?
No, I think what is the problem that I often see is that people have this mentality going in like a code review kind of mode, where they think that their job is to say it's wrong. And I often think that often that is also a problem with code reviews. I think we should probably just say that for every bad thing you say in a code review, you should say something good.
Yeah.
You'd be like, I really like how you did this thing, but over here maybe this could be a little bit different. Maybe we should have a rule, we have to say something nice, because I think as developers we get a lot of negative feedback. Our whole process is driven by bug reports, basically saying it's wrong.
Yeah.
We generally don't get a lot of positive feedback, and so we kind of need to build each other up a little bit and support each other. And so I think, yeah, I've totally forgot your question now.
It was just about incorporating this into a team and actually, making this a real way that your team works.
Yeah, so I definitely think trying to read other people's code, trying to learn their style. Once in opera, I wrote a whole class in somebody else's style as a tribute. It's like I would never write code like this, and I was like, but I liked his style. It was totally different from mine, but it was very minimalistic, and so I wrote the whole class, and I brought it to him, and I showed it to him, and I was like, so what do you think? And he was like, yeah, it looks good. And I was like, does it remind you of someone? And he was like, yeah, kind of looks like mine, doesn't it? But it's, so we can be, make this a positive experience.
Yeah. Oh, okay. I think that's fantastic. All right. Are we ready for our next one?
Yeah.
Okay. All right. Thank you so much, Patricia.
It was my pleasure.
All right.